Hello and welcome to my YouTube channel. Today in this video we are going to learn how to print the ADC data on the UART console. Again in this project we are using STM32F44 6RE microcontroller board. This is the second part of the video. So this is second part, that means 7B. First part was 7A. Now let us talk about the coding part of this video. For the coding part, we will include some header files which are related to standard input and output and string functions. So these header files will provide us all the necessary functions or APIs to conduct the standard input output operations and string functions. We will declare and initialize some variables. We will start the interrupt based ADC so that we can use the CPU more efficiently. Then we will interrupt the interrupt service routine callback function, and in that callback we will get the ADC value. Then we will convert the ADC value to its equivalent voltage. Then we will convert the voltage to its equivalent temperature, and then print the above values on the UART console. Then at the end we will stop the interrupt and repeat the process. Now coming to the hardware connection, we will be following the same connection that we are following since last 4 videos. So the leftmost pin of the LM35 will be connected to 3.3 volt. Middle pin will be connected to the ADC channel number 1. Okay, and then rightmost pin will be connected to the ground pin of the microcontroller board. So this is all required for the connection part. Now let us see the coding part. So open the STM32Cube IDE. Click File, New, click on STM32 project. So we'll be starting with a new project. Now after this we will get this window which asks us about the board selection. So we will go to the board selection and type F44 6RE. So we will be using Nucleo F44 6RE microcontroller board, and then after that click Next. Now we will have to provide a name to the project. So let me give it a name. You can say ADC underscore UART underscore print. Okay, print underscore value. Okay, value. So this is our project name. Click on Finish. Initialize all peripherals with their default mode. No, we don't want to initialize all the peripherals in the default mode. So therefore we will select No. This will take us to the CubeMX perspective where we will initialize the hardware which we require in our project. So for that, before going for initialization, let me go to the pinout, clear all the pinouts, and we will get a warning that pinout configuration will be cleared. We will say okay, no issues. We will click Yes. After this we will have to make some changes in the configuration. So go to the RCC first. Okay, and then select the high speed clock, crystal ceramic. Select the low speed clock, crystal ceramic. Okay, and then go to System. For debugging purpose we will use trace asynchronous SW. That's all. So system core related functionalities have been completed. Now let us go to the analog part. Since we are going to use ADC1, okay, ADC1, and we want the PA1 to be initialized. So click on In1. Now we can see pin A1 has been initialized with the ADC functionality. Like in the previous videos, we will enable the interrupt. For that, you have to go to NVIC and select this interrupt. So ADC related operations are over. Now let us use the connectivity section. Come down, select UART 2 because this is the UART which users can use from the STM32F44 6RE microcontroller board. So first of all, let us enable the mode. So we are going for asynchronous communication because UART is an asynchronous communication. And you can see automatically UART 2TX and UART 2RX are enabled on pin number A2 and A3. And now we can just change the baud rate here. So the baud rate we are going to use here is 9600. You may use any baud rate which is in the list of baud rates which I have covered in the previous lecture. Now remember, word length is 8-bit. Parity, we are not using any parity bit here, and stop bit is 1-bit length. We can change 1 or 2-bit depending on our choice. I have covered all these details regarding the parameters in the previous video. So now we have completed our configurations. So we can click on either device configuration, tool code generation, this gear button, or you can also use save all. You may use any one of these options. And now after clicking save all, we get a message, do you want to generate code? Yes. And now from here we will enter into the C perspective where we will have to write our program. Now for writing the program, we have to go down. First we have to include the header files. So we can come to this part, user code begin includes. We can just use include standard stdio.h. Okay, so for autofill you can use control space hash include string .h. These two header files are required for standard input operations and string operations. Now we will come down and we will declare some variables. So here is the user code begin private variables. So we have to include int ADC underscore value. Okay, int temperature, then int ADC underscore resolution, and we can recall the ADC resolution in our case is 4096, which is basically 2 to the power 12 because our ADC in STM32F44 6RE microcontroller is 12-bit long. Now we have to include some more variables. So voltage and float V underscore ref. If you recall, voltage reference is 3.3 volt, which is connected to the VCC pin of the LM35 temperature sensor. And then we have to include one more variable, temperature coefficient. Okay, and if you recall, the temperature coefficient's value is 0.01 because the temperature coefficient of LM35 is 10 millivolt per degree Celsius. And char ADC underscore valid, and then char, we are going to create an array of 60 characters to print all the messages. So therefore we are using this char message 60. Okay, so this is all about the variable declarations. Now we will come to the user code begin section 2. where we will initialize the ADC. So remember, we are going to initialize the ADC or start the ADC in with interrupt. So we will use this third function, start ADC with interrupt, pass the handler and semicolon. Now let us go back to the user section 4. Let me just minimize these windows because these are taking too much space. Minimize this. Okay. Clock configuration, ADC initialization. These are all generated by the STM CubeMX. You can see here baud rate is 9600. Word length is 8-bit long. Stop bit is 1. No parity bit is used in this code, and there is no hardware control also. Hardware flow control, sorry. And minimize this window. So now come down and we can write our callback function here. If you recall, the callback function is in the drivers, STM hall driver, source, click on ADC, and we are going to use the callback function which says hall ADC conversion complete callback. So once the conversion is completed, the ADC will generate an interrupt and the CPU will go to this callback. And remember, this callback is weak, therefore we can use this function in our main program also. So copy this function, go to the main and paste it here, and let us write the code in this section. So if HADC is receiving the value from the handler 1, in that case first we have to get the value of ADC. So ADC underscore value, okay, ADC value equal to all underscore ADC underscore get value. Okay, pass the handler and semicolon. So this will get the ADC's value, which will range between 0 to 4096. Now we will convert the above ADC value to its equivalent voltage and store it in the voltage variable. For that we can use ADC underscore value multiplied by V underscore ref divided by the ADC resolution, ADC underscore resolution. So this will convert the above ADC value to its equivalent voltage. Now we will have to convert the equivalent voltage to its equivalent temperature. For that we can use voltage divided by temperature coefficient. Okay, that's all. So till this part we have completed in the previous videos also. Now let us print the value on UART console. For that you can go to sprintf. Okay, and now we can pass the message. My mistake, something, oh no, okay. Sprintf message, comma, so measured value of ADC 1 is, you can print the value %d. %d represents decimal value, okay, and return carriage, comma, ADC underscore value. Okay, we will print the value here. Now sprintf stores the value or this message, and ADC value, this variable goes to %d. So the message will store measured value of ADC1 is ADC value. Now we will have to pass this message to the UART. For that we can use hol UART underscore transmit. Now pass the handler. So UART handle 2 data. Data is our message, but message we have to first convert it into uint underscore 8-bit message. Okay, so uint underscore, wait a second, int 8 underscore t, because character is 8-bit long, and typecasting the message, and then after that, okay, typecasting the message, and size of the message is the size of string. So string str length of message. Okay, and timeout, we can just use a small timeout of 20 millisecond and semicolon. So this will complete our printing of first message, which is measured value of ADC1 is the value of ADC. Let us copy this part and paste it here. Now here in the next line I am going to print the value of temperature. So measured value of room temperature is, okay, %d. I'm going to add one more new line so that there will be a gap between these two messages. So you just have to remember, in the first we are using only single return carriage, and here we are using 2 returns, so there will be a gap between these two. Instead of ADC value, I will use the temperature. Okay, temperature, comma, I can just print in degree. Okay, and done. So this is all about the message. So we are going to print first message, which will take the value from the ADC value variable, and second message will be taken from the temperature variable. Okay, and then after transmitting the message, we have to stop the ADC. So hol underscore ADC underscore stop. But remember, instead of using normal stop, we have to stop the interrupt based ADC. So we will be using stop underscore IT semicolon, and then we will make a variable ADC underscore valid equal to 1. This is all required for the callback function. Now let us go to the while loop. Here in the while loop, remember, put your code between begin 3 and end 3. Otherwise, whenever you make any changes in the CubeMX, all the codes will be deleted. So let us fill the code here. So if ADC underscore valid equal to 1, in that case we have to make the ADC underscore valid equal to 0, and then start the hol ADC again. Hol ADC underscore start it again. Remember, start it with interrupt. So start with IT, pass the handler semicolon, and like in the last part, we can just add a small delay, hol underscore delay of 500 millisecond in the while loop. So this is all the code. So let me just summarize the code once again. We included 2 header files, studio.h and string.h, and then we included some variables. ADC value, temperature, resolution 4096, voltage reference which is 3.3, temperature coefficient 0.01, ADC valid, and message. This is an array which can store up to 60 characters. Done. And then we started the ADC with interrupt. For that we included our code in, let me just go to the begin section 2, begin 1, begin section 2 here. Okay, so we started the ADC with interrupt. Then in the while loop we checked if the ADC valid variable is 1. In that case, make it 0 and start the ADC with interrupt. Provide a small delay and keep checking. If the ADC valid is 1, make it 0. And for the interrupt part, we use the callback, and we filled the callback in the user section begin 4. Okay, so callback, if the ADC gets any converted value, then in that case this callback will be generated or called. Then we read the ADC's value, convert it into voltage, convert the voltage to its equivalent temperature, store the value in a message. So the message will be measured value of ADC is ADC value. This variable's value will be stored here in the %d. Then a sprint message, and then we will pass it into the UART with a small delay of 20 millisecond. Then again we use the sprint message, where the message will be the measured value of room temperature is %d. Here we are returning 2 times so that there will be a gap of 1 line between the 2 messages, and we will print the temperature here in the %d, and then we will print degrees and pass it to the UART. So let me just and then stop the ADC interrupt and make the ADC valid. So if it is valid, again it will go to the while loop here, and while loop will run this part again. So this is all the coding part. So let me just build the code and check if there is any error. So there is one warning: too many arguments for the format. So here there is a warning. So let me just cross check if there is any error in the code. Okay, so this is related to our temperature. Let me go down and check if there is any error. So let me just minimize these initializations. Okay, these are not needed. Let us check. So temperature is getting the value temperature and degree. Okay, so let me just make the array a bit bigger because it might not be able to accommodate that message. So let me make it 80 characters long. Still I am getting the error or warning, not an error, too many arguments for the format. Let me just go down and change that length. So instead of measured value of room temperature, I can just say current room temperature is %d, and of course for this degree we have not initialized any folder. So %s string. So this degree is string which will be stored here. Temperature will be stored in this particular decimal value. Let me just rebuild the code, and we ended with 0 error, 0 warning. Now let us check how we can find the UART port to which our microcontroller board is connected. So I will connect the microcontroller board, and here the board is connected with the temperature sensor. And let me go to the the properties of the PC. So you can just right click on your PC icon and go to the properties. Come here to the device manager. Click on the device manager, and inside the device manager go to ports and check to which port your STM microelectronics is connected. So STM microelectronics virtual COM port is COM port number 8. Note that number, and then we will make some changes in the COM port. Okay, so in the STM cube ID. So just now debug, click on the debug button, click OK. Just for time being, let me stop the video because we will be making some changes in this corner. Okay, so now our program is waiting. We can go to the live expression. All the variables are here: ADC value, temperature, voltage. We want to print it on the UART console. So you can go to the rightmost bottom here, open console, click the arrow here, click new console view. New console view. Okay, we are getting some message. Let me just close the connected. Let me disconnect this. Okay, delete this, and let me go to command cell. Okay, and for new connection you can go to select. Remember what I did here? Click here on the new console view, click down, come down, console command shell. Okay, command shell. Now after that you can select new serial port. Now click on new, give it a name. So I can call it UART new underscore connection, and then remember COM port 8 which was connected at we noted from the port in the device manager. Change the baud rate to 9600 which was set in the CubeMX also. These two numbers should be same. Data size is 8-bit. Parity is no parity. We are not using any parity. Stop bits only 1. And finish. And click OK. Here we can see UART new connection connected. So connection is made, and we have to now click on resume button, and we can see the measured value of ADC and corresponding room temperature is getting printed on the UART console. So let me just start the camera, and let me pinch the temperature sensor, and we can see the temperature is rising. 31 degrees Celsius, 32 degrees Celsius, 31. Okay, so this is what we can do with the UART console. And you can cross check the temperature in the live expression window on top right here, 30 degrees Celsius, and we are getting the same message in the UART console also. So with this, I would like to end the presentation. If you have any doubts or suggestions, please share your doubts and suggestions in the comment section. If you have not subscribed the channel, then I would request you to please subscribe the channel and click the bell icon so that you will get the notifications as soon as I upload a new video. Thank you and have a nice day.